Transform the graph of y equals the natural exponential raised to the x to make it into the graph of y is equal to minus the natural exponential raised to the x plus 4. Then give the domain and range of this transformed function using interval notation. So, to begin, we are given the parent function here. That's the natural exponential raised to the x power. So our parent function is f of x is equal to the natural exponential raised to the x. Now, real quick, let's just think about what the exponential curve looks like. So here is our xy plane, and we know that the exponential curve looks something like this, growing infinitely large as x gets bigger and bigger. And we know that this graph has a y-intercept at the ordered pair 0, 1. So we're going to use this graph as a reference point as we identify the transformations to attain the desired graph. So looking at that desired graph there, reading the transformations from the left-hand side to the right-hand side, the first thing we're noticing is a negative in front of the exponential. So the first transformation we're observing is minus f of x, which is minus the natural exponential raised to the x. So let's recall that our definitions here. If we're multiplying a function by a negative value, what are we doing? We're reflecting the basic graph or the parent function across the x-axis. So we are reflecting y equals the natural exponential raised to the x across the x-axis. So that's our first transformation. And let's think about how this would affect the graph above. So again, we are thinking about the xy plane. So here's our y-axis. Here is our x-axis. Beautiful. And we're taking that above graph and now reflecting it across the x-axis. So this curve has the same shape, except it's below the x-axis. So we have now a y-intercept at the ordered pair 0, -1. And again, this is the graph of y equals minus the natural exponential raised to the x power. Beautiful. So again, looking back at our desired function, reading those transformations from the left to the right, the next thing that we're noticing is that we're adding 4 to this function. So what does this mean? So if we are taking the function from our first step here, minus f of x, and we're adding 4 to it. So notice we're adding 4 to the y values here. So thinking back to our definitions, we realize, hey, we're vertically shifting up 4 units. So we're going to take that graph and shift it up 4 units. So we have identified all of the necessary transformations. And now we want to think about the graph and giving ourselves plenty of room. Let's think about our coordinate plane. And now thinking back to step 1 here, we're going to use this y-intercept as a focal point. And we also want to keep in mind that the graph of the exponential has a horizontal asymptote, in this first case, at the x-axis. So this graph has a horizontal asymptote at y equals 0. So with that in mind, again, we are going to start by thinking about the y-intercept. So down on our new coordinate plane, here's where that original y-intercept would be. And we want to take this now and shift it up 4 units. So we have 1, 2, 3, 4. So our new y-intercept is occurring at the ordered pair 0, 3, which means that the graph of this shifted exponential function is going to have a horizontal asymptote when y is equal to 4. So we'll draw a dotted line there to indicate that a horizontal asymptote exists. This is our horizontal asymptote at y equals 4. And again, the shape of this exponential curve will still be the same. You can get infinitely close to that horizontal asymptote, but the graph will never cross. Beautiful. And so here is the graph of the function y is equal to minus the natural exponential raised to the x plus 4. Now, looking at this graph, we can see the domain and the range. Right? We already know from definition of an exponential function that this function exists for all x values. So we can say that x can be any real number our little hearts desire. Now we want our final answer in interval notation, so we can say that x is an element of the interval from negative infinity to positive infinity. Beautiful. Now, we also need to consider the range, or the set of all possible y values. So keep in mind here that we have a horizontal asymptote when y is equal to 4. So the graph of this exponential cannot cross this horizontal line. But we can see the graph could be anything, or could attain any y value less than that. So for the range, y is going to be strictly less than 4. But again, that's our inequality notation. We want our final answer in interval notation. So we can say here that y is an element of the interval from negative infinity up until and excluding 4. And so there you have it. This is the domain and range of our transformed natural exponential function in interval notation.